Take this problem. Light travels in a medium into mediums M1, M2 with speeds given. The critical angle between them is. Now they ask me to find the critical angle. Right. And what's the critical angle formula?
So sin inverse of refractive.
So this means theta c, which will be equal to what we tell now sine inverse half. We can say this as mu r by mu b. Refractive index of rare medium by refractive index of denser medium. Okay. Now you tell me now here they given the speeds they given. As we know, speed in any medium which is given as what tell me now that is equal to c by refractive index c by refractive index. Now, so from this you can find this is mu is equal to what we can say now c by v na mu equal to c by v, right? Now let's find out now here c. Now in the how the speed of light here mu r means what I mean rare medium. Rare means how the speed of the light is more or less. Yes, now here mu r by mu d. So that means how we can write now here speed. So what will be the rarer medium? What is the denser medium here? From this we can say refractive index of rare medium is given as what tell me now? C means what tell me now 3 into 10 power 8 by V. What is the V to be taken now here? 2 into 10 power 8 or 1.5 into 10 power 8?
10 power.
Yeah, so that is how much this value will come it as 10 power 8 na will come to be a 3 by 2. Now refractive index of denser medium. So that is given as 3 into 10 power 8 by how much now? 3 by 2 we can write now into 10 power 8, which will come to be what tell me now 2, right? Now we can put these values now to get the value of theta c. So how much the theta c value? So that is sine inverse of what tell me now mu r is 3 by 2 by 2. So how much the theta c value now? That is sine inverse of 3 by 4. Then what's the option? Then what's the option? Option then. No option. Here we have the sine we have. So here other angles also there now. So we need to get other angles. So we'll find, we'll check it. Cos is there, tan is there. So how will get these other angles? Get the other angles now here. So since we got this as this angle theta c. So sine theta c, which will be equal to 3 by 4 now, opposite by hypotenuse. Then what is this thing here now? So 16 minus 9. Yeah, so this is, so from this, what we can write, to tell me? Uh, so from this, we can see instead of a sine, they give a tan theta c, which will come to be what, tell me now? 3 by root 7. Okay. Consider a light ray traveling in air is incident on a medium of refractive index 2n. The incident angle is twice the refracting angle. They are asking to find the angle of incidence is. Yeah, do this one. Incident angle is twice the refracting angle. Angle of incidence is twice the refracting angle. So means what you tell me now, they given. So this angle of incidence I is equal to what, tell me? I is equal to 2r, they are saying. Now we can apply the Snell's law. And here medium 1 is A, medium 2 refractive index is given. So that is mu1 is what, tell me now? 1. And that is mu2, which is equal to what, you tell me now? Root 2n, isn't it? So let's apply the Snell's law here. Snell's law. So that is mu1 into sine I equal to what, you tell me now? Mu2 into sine R. So this mu1 is 1. So this is sine I, which is equal to 2r, which is equal to mu2 means, so this is root 2n into sine r, isn't it? So this sine 2 theta form now, we can say now 2 sine theta cos theta. 2 sine r into cos r, which is equal to what, you tell me now? 2n into sine r. Okay. So this sine r will be cancelled. So I will come this as cos r from this, which will come to here. So this is root n by 2. So this means we have this r value is cos inverse of square root of n by 2. From this I is equal to what, tell me now? 2r is equal to 2 into, this is cos inverse of root n by 2. Okay. Option D. Got it. A transparent solid cylindrical rod has a refractive index is given. Okay, it is surrounded by air. A light ray is incident at the midpoint of the one end of the rod as shown. the incident angle theta by which light ray grazes the wall of the rod. Understood this one? Option 1. Right, look at now here. Light ray grazes the surface. Means what you tell me now here. So here, this is the angle of incidence. This is the angle of incidence. If I call this as I, right? And here, this is the angle of refraction. Angle of refraction is how much now? Which is 90 degrees. So that means I must be equal to critical angle, isn't it? I must be equal to critical angle. Okay. Now, what we can do here? If we apply the Snell's law, so this I, where I must be equal to theta c only, na? How much is theta c value? Which will be equal to sine inverse of mu r by mu d. So that means I is equal to theta c, which is equal to sine inverse of what terminal mu r is 1, and this is what terminal 2 by root 3. So that means I is equal to theta c is equal to sine inverse of what terminal root 3 by 2. Then how much this angle you tell me now, which will be equal to 60 degrees now? Sine 60, sine 60 value how much? Sine 60 value how much? Sine 60 value how much? Root 3 by 2, isn't it? Now take the sine to other side. So that means 60 equal to what you tell me now? Sine inverse of root 3 by 2. Okay. So this means. Right. So this angle we got it as a 60. Now this angle of incidence which is 60, right? Now if you see carefully here, this thing, here this angle is 90. Yeah, so this is now here. Then if I call, how much this angle you tell me now? If I call this angle is something, so here, some x if I call, so how much this angle? This angle we got, this is the I is equal to theta, that is 60. So this means this angle must be 30 degrees now.
Yes.
Yeah, so this angle 30, this angle 30. Now we can apply Snell's law. We apply Snell's law, right? Tell me now, apply the Snell's law. This medium is air, this having some refractive index. Okay, so this is, we can say 1 into sine theta, which is equal to what, tell me now? 2 by root 3 into what you tell me now, sine 30 na? Snell's law here. So that means sine theta, which will be equal to 2 by root 3 into 1 by 2, which will come to be what, tell me now? Yes, so theta is equal to sine inverse of 1 by root 3. Okay.
Yes.
Yeah. This one, in a minute. Yeah, completed. 3 by 4, which will be 57 degrees. No need. So in those cases, we'll keep like this, we'll simplify it. We can get the other angles, required angles we'll get now. Tan 3 by 4, 37. So here and 53 degrees. So you can remember this thing, sine 37 degrees, which will be equal to 3 by 5. And cos 37 value, which is 4 by 5. Next, sine 53 degrees, which will be equal to 4 by 5. Cos 53 degrees, which is 3 by 5. Now, if fish is looking up through the water, see the outside world contained in a circular horizontal surface. If the refractive index of water is given and the fish is at 25 centimeters below the surface, what is the radius of this circle? So this is comes under circle of illumination. Yeah, so there we have seen now. Here is a fish and this height is h, right? And here from here to here, it will form this circle. The radius of this circle we need to find. And this radius is r. So this angle, which is theta c. Now tell me now where this r is equal to what we can say now, h into, no, tan theta c, tell me now. So, and so we need to get whatever tan theta c value. Here we apply the Snell's law, we'll get the relation now. So if we apply, so theta c value, how much now? That is sine inverse of, what, tell me now, mu r by mu d. So 1 is 8, so that is 1 by 4 by 3 now. So we'll come it as theta c value is how much now? sine inverse of will come it as 3 by 4. Now, but here, so from this we can get it as what? Tell me now, sine theta c value. How much is sine theta c value? 3 by 4. And we'll get the tan theta c from the triangle. How much the tan theta c from that? Yes, so this is angle. Sine means we can say now 3 and this is 4. And this value how much now? Root 7 now. From this we can say now tan theta c. How much the tan theta c value? 3 by root 7 tan theta c. Now from this we can get this r value. No, take the sine to this side. Hmm? So take the sine to this side, yeah? Hmm. Then we'll get the sine na. We'll get sine theta c will come now from that. How much will come then? So this is r is equal to h. H value how much now? 12 centimeters now. Yes, 12 into which will be equal to 3 by root 7. Isn't it? So this value equal to 36 by root 7 centimeters. Okay. So they ask an answer in centimeters only. So this is option. Got it? Next one. Light ray refracted from one medium to another. The wavelength changes from 4,500 to 3,000. The critical angle for a ray from second medium to first medium is critical speed also. Yeah, critical angle formula. So that should be given as sine inverse of what we can say now. This is mu r by mu d. And wavelength in any medium, which is given as what? Tell me now. Wavelength in air by refractive index. If the medium is denser medium, wavelength is low. Rarer medium, wavelength is high. So that means here the mu is equal to what we can say now, lambda naught by lambda in a medium. Lambda naught means wavelength in air. So now you can see now here the denser medium wavelength is low. So here we can say this is now wavelength is high, mean that is a rarer medium only. So mu r is equal to lambda naught by high means 4,400. And similarly mu d equal to what? Tell me now. Lambda naught by 3,000. So from this we can get the critical angle. So that's why theta c, which will come to be a what? Tell me now. Sine inverse of mu r by mu d. So that means what we'll get now here. So that is 3,000. 3,000 by 4,100. So simplified, tell me the answer. Two zeros will get cancelled. 5 and this is 9, na? So this values theta c, which will come to be a sine inverse of 2 by 3. Okay, option is there. No option. So convert into some other angles now. Now this sine angle. So this is 2, this is 3. So that is how much now? This is root 9 minus 4. That is 5 now. This is theta c. From this we can get the tan theta c. How much value? 2 by root 5. So that's why theta c equal to tan inverse of 2 by root 5. Right. A light ray is traveling from a denser medium into rarer medium. The velocities they given. Critical angle they asking. Yeah, do it now. And denser to rarer medium. Yes, so what is the critical angle now? Theta c. And that should be equal to sine inverse of mu r by mu d. Now you can see now here this is sine inverse of mu r. So that means this we can write it as if the velocity, if the refractive in case of rarer medium, velocity is high. Okay. Denser medium velocity is low. Right. So how much is what is this mu r value we can write now basically that is equal to c by what I mean rare medium is high now, so that is 2.5 into 10 power 8 will come. C means how much? 3 into 10 power 8. Next, mu d is how much you tell me now? So that is 3 into 10 power 8 by, so this is how much now? 2 into 10 power 8. Now simplify it. Then will come to be what, tell me now? 2 by 2.5 now, isn't it? So this will come to be what, tell me now? Sine inverse of, we can say now 20 by 25. So that, yeah, so that is sine inverse of 4 by 5. Second option. Next. Light takes time t1 to travel a distance x1 in vacuum and the same distance t2 to x. Same light takes take t2 to travel x2 distance in a medium. Critical angle. Tell me what we can write now first of all. So this is T1. T1 is a time taken by the light to travel in a vacuum a distance of x1. So T1, which will be given as x1 by vacuum, means air only now, the speed is c only. Okay. From this, which I can write it as c is equal to. So this is x1 by t1. C is equal to x1 by t1. Next, in a medium, so that is t2, which will be equal to t2, which is equal to what we tell me now, x2 by speed in a medium. So this can be written as what, tell me now, x2 by what we can write now here. This is uh, this one c by mu na. So mu will go to numerator. So now we'll come it as what has been so this value from this get the new value. Mu is equal to c t2 by x2. C value we have now, so we can place it. So this is x1 by x2 into t2 by t1 now. Now what is the theta c now? Yes, sine inverse of mu r by mu d. Mu r means greater medium is air only. Na? So the refractive index is 1. So that is theta c, that is given as 1 by mu. So that's why theta c will come to be a sine inverse of 1 by mu. Means what are we now? x2 t1 by, so this is x1 t2. Okay.
Yes, sir.
See the option now. Yeah, fourth option. An underwater swimmer looks upward at an unobstructed, overcast sky. Obstructed, overcast sky. The vertex angle subtended by the sky at the swimmer's eye is how much? The direct one now. They given P is the critical angle. How much the vertex angle they ask him to find? How much the vertex angle?
Two.
Hmm. This is the critical angle theta c. The vertex angle means this whole angle na. So this is so vertex angle which is equal to 2 theta c. So that means 2c. Next one. Yeah, you can do it. A point source of light is placed at the bottom of a water tank. If the area of the illuminated circle on the surface is equal to area equal to 3 times the square of the depth of the lake.
Sir,
The
what is the
depth means height now. Where the point source is placed at the bottom. Recollect the circle of illumination concept. Mm. At the bottom of the lake, point source has been located. Here we have the circle of illumination will be formed here, and this radius is r, and this angle which is theta c. So this medium will consider this as air, and this is the water. So this refractive index is mu. So the relation we know now, first of all, is R is equal to H tan theta c. And what they given now, the area, so that means pi r square area. They given us how much, you tell me now, this area which is equal to 3 times the depth, that means 3 h square. Area means pi r square, which is equal to 3 h square. That means pi into h square into tan square theta c, which is equal to 3h square now. That means pi into tan square theta c, which is 3. That means tan theta c, which is equal to how much now? Root of 3 by pi. Now, what is a refractive index means what? Tell me now. What is the theta c basically, which is given as sine inverse of mu r by mu d. Here mu r is 1, so that's why it will be sine inverse of, will have 1 by mu r refractive index of a water. Now from this we can say this as sine theta c, which will be equal to 1 by mu. That means mu is equal to 1 by sine theta c. Got it? So that is mu is equal to 1 by sine theta c. Now we have the tan theta c, we have theta c, which is equal to square root of 3 by pi. From this, let's get the sine angle. So this we can write as root of 3 by pi by, this is 1, this angle theta c. So this will come to be what element of 3 by pi plus 1. So that is mu is equal to, from this triangle sine theta c means how much? Is equal to square root of 3 by pi by, that is root of 3 by pi plus 1. Now for this 1 by means reciprocal. How much will come? So this value, reciprocal of this thing now, so it's square root of 3 by pi plus 1 by square root of 3 by pi. Then this we can write it as under root of, this is 3 by pi plus 1 by 3 by pi. Split this division for both, then this value will come to a square root of, this is 1 plus, will become pi by 3 na? Reciprocal. Finally, the answer you can see now. So second option. Understood how you need to approach this problem. Next one. Now, for instance, if the reflected and the refracted rays are perpendicular to each other, they ask in different critical angle. Right. And so let us say here this is a normal. Here the two light rays are incident here. A ray of light will incident, the light ray is reflected, and here, and this light ray is refracted. Right, so this angle is angle of incidence I, this is reflected angle is also I only, refracted angle, this is R. Okay. Now, so what they're saying here, we see the reflected, and this is refracted. This angle given as a 90 degrees, and they're saying now it is moving from denser to rarer. So this medium refractive index is a mu d. This medium refractive index is mu r. So you can see now. Now this total angle which is 180. So we can write it as I plus this is 90 plus r, which is equal to 180. Then it is I plus r, which will be equal to 90 degrees. Then we can write it as r is equal to this is 90 minus I. right? Now we apply the Snell's law. So it should be equal to mu b into sin I, and which is equal to mu r into sin r. Sin r equal to what will be now 90 minus I. So it will come to be a mu d into sin I, which is equal to what will be now mu r into this is cosine. Then will come it as, so here this is sin I by this is cosine, which will be equal to mu r by mu d, right? And with the critical angle formula, that is theta c, which is equal to sine inverse of mu r by mu d. So that's why theta c, which will come to be a sine inverse of here mu r by mu d, which is nothing but tan I na, is tan I. Got it?
Yes.
So this is the options. Take this thing. Of refractive index 1.5 is immersed in water. Of refractive index 4/3. For total internal reflection, the correct choice is, that means TIR has to happen. TIR is occurred, tell me first of all, where the TIR is occurred. Here. Yes, at this location, TIR is happened. Yes or no? The light ray is fall and will be reflected back the same medium. So, right. Now the conditions, let's understand option 2. So fine, look at now here. This is the normal. This is the angle of incidence. This is I. Okay. Now, so for TIR to be, so this is I must be what will be now greater than theta c, right? So this is I must be greater than sine inverse of what we can say, tell me now, mu r by mu d. Okay. Now, so let's focus about this I value. So this is I that must be greater than sine inverse of what you tell me now here. How much is mu r is a refractive index of, so this value it is 1.5. This is 4/3 means 1.33 now, isn't it? So that means mu r means how much now? So this is 4/3 is a mu r now, and this is 3 by 2. This is the bigger value, isn't it? So this means I must be greater than sine inverse of what we can say now here 8 by 9. Right? So this means I. Now if we have observed this thing here, I must be greater than this much. But we need to focus about theta na. So this angle theta given, then this angle is also theta only na. Yes, then this angle theta, then this angle is 90 minus theta. Yeah, then what happens now? Obviously, so this angle is this theta only na. Here I is equal to theta. Yes or no? Yes, so this I and thetas are equal. So that means theta must be also greater than sine inverse of 8 by 9. So from this we can write it as sine theta must be greater than 8 by 9. Okay, second option. Try this pen. A light ray is incident at an angle of 45 degrees on a parallel sided glass slab and emerges grazing the vertical surface. The refractive index of the slab is. Now the light ray is incident at an angle of 45 degrees on a parallel sized glass slab. So means you can see now. So this light ray which is incidenting on it this glass slab. So at an angle of 45 degrees. 45 degrees. Thereafter the light ray is grazes the surface. Mean the light ray has to move like this now. Okay, here they are asking the vertical surface, na? Grazes the vertical surface. Okay, in that manner, we'll do that. Here they given it as it is grazes the vertical surface. Means this mean to say here the light ray which will incident. We have taken. So fine, we have considered this thing here. And so we can consider this light ray which is incident like this. Incident like this, thereafter it will grazes the surface like this. Now this is the angle of incidence. This is must be a theta c, right? And the theta c given us 45 degrees indirectly. So you can tell me now here how much will come here. You can apply now here theta c, which will be equal to, that is sine inverse of, that is mu r by mu d. So that means theta c, which will come to be a sine inverse of mu r is 1 by refractive index of a glass slab we have taken as a mu. So then it will come to be what we now have sine angle given 45 degrees. Yes, so then it will be 1 by mu now. 1 by mu. So then it is, yeah. So then mu value root 2 now. So wait, is option root 2 only. So this is refractive parallel sides. Whether they given the angle with the surface, they may given check it. Okay, even though that also same only. Root 2 is correct answer. Correct only. Root 2 only answer. So this is root 2 is answer. Okay, so this is the option. Right.